Welcome back, guys. This will be day 9 of me trying to learn TypeScript. So today I'm going to be doing type narrowing. And yesterday, when I was doing enums, I said I'm doing unions because I prefer unions over enums. Okay, yesterday I did enums, and then today I'm going to do type narrowing. So type narrowing, if I understand it, is like using in TypeScript, if you use an if statement, you can use an if statement to narrow your type. So that's, I think, what we're going to be learning, something along those lines. Okay, so I'm just gonna try to understand. So I just finished revising enums, and then the guy was saying you don't really need to use them, just have to know them anyways because they're like bad and stuff. They result in a new bigger JavaScript bundle because the code will be there. As with unions, it will only select the one that you're gonna narrow, if I may say. So yeah, I'm just gonna read some narrowing types. I'm at res, and university residents, they are noisy. MFers are making noise, as you can hear in the background, but we get what we get. So narrowing types. Type narrowing is the simple process of making a type more and more specific as you write your code. As a general use, don't abuse it. For the love, the more specific your types, the better. Okay, with narrower types, your editor tooling will be more helpful. Your code will be self-documenting. You'll catch more errors at compile time. So I've noticed, when I'm reading something, I don't really read what is written. I just say something along those lines. I don't know why. This is what makes me start, I think. Conditional narrowing. Okay, I'll just letting it known out there. So conditional narrowing, I think this is where you use ifs. One of the coolest feature of TypeScript is how smart it is. Okay, how smart it is about recognizing how types are being narrowed in regular code. For example, if you have tagged union or a discriminant, it's a tagged union. Okay. Function fight, player 1, player 2. Then if you do this, you've narrowed a type. Yeah, if the type equals to Witcher and type 2 equals to Witcher, then you do this. If type 2 is equals to Star Wars, and then the Star Wars, and then you do this, and then else can't fight character from a different universe. Okay, this makes sense. Witcher and Star Wars can fight from different universes, whatever. Okay, I don't need to typecast convert player 1 and player 2 to Witcher character, because TypeScript does that automatically, because this branch of conditional narrows the type. Yeah, you can use if statement to narrow the type. So yeah, this is really interesting. Yeah, and then your fight Witcher, fight Star Wars logic would come here. Okay, then you have your assignment. Support AI provides 2 plans, regular and premium. Regular customer have a limit of 10 tickets. Premium users do not. Okay, take a look at the open ticket function and notice that its current state produces a compiler error. Fix the bug by using type narrowing. The compiler should know that above limit exists on the customer when it does that specific check. Okay, so you narrow the type, checking if it's a regular customer, and then fix the bug. The compiler should know that above limit exists on customer when it does a specific check. Let's see. So here we'll just do customer, and then what do we do? Take a look at this provides an error because above ticket does not exist on everything, right? Yeah, so you would want to use regular plan. You would want to use plan. If it's regular, do something for regular. Wait, it's incrementing the tickets. Yeah, whatever. Let's just see the tests. They're just doing something. Yeah, plan regular. You just check the okay, look, in the end we're incrementing the ticket by 1 or whatever. So you would just use plan instead of above ticket because they both have plan. Okay, that's what you would do. let's move on, because like there are 10 levels. It might be the longest video if we waste time on doing that. Unknown type, we've talked about the any type in TypeScript and how it can present anything. Okay, it's the weirdest type. The unknown type can be used for similar purposes, but it's a much safer alternative because it forces you to explicitly assert the type before using it in any specific way. Okay, the any type basically turns off TypeScript type checking. Okay, yeah, that's what it does. Simply just says it can be any type, so don't check. TypeScript allows this even though it might crash. TypeScript allows these two. It's like we're using plain JavaScript, non-existent methods. No errors when calling them. Okay, it's like we're using plain JavaScript, so like it won't check if like this data is like a function. It's like an object with a function, whatever. Okay, as we've talked about earlier, when you take plain JavaScript code and run it through TypeScript tooling, almost everything is any by default. The unknown solution, the unknown type doesn't allow that kind of tomfoolery. Yeah, the function process unknown, error object is of type unknown. Okay, object is of type unknown. So what does it do? With unknowns, you can still assign any value to it. Call this function with any value, but you can't use that value in a meaningful way with that. Okay, so you have to like narrow the type first before doing something. Okay, so you can pass in any value, but it don't allow you to just use that value. You have to do some type narrowing. We do a typization, type of data. If it's string, then we can do lowercase. Type of data if it's number, then we can perform arithmetic operation, throw an error for other types that we can't handle. Yeah, this is great. This is amazing. When to use unknown. Unknown is a fantastic alternative to any when it comes to dealing with values that are coming into your program from the outside world. User input, API responses. It forces you to add type checks at that IO boundary so that you can be more confident working on the data inside your program. Okay. Yeah, I like unknown. I'm gonna use it instead of just saying any when I don't know the type, so that I do some type narrowing before using that value. This is great. Assignment supply needs a robust message parser that handle email inputs which are received as strings. Okay. Or chat inputs which are received as arrays of strings. Okay, complete the pass customer message function. It receives an unknown input and returns customer message. Yeah, and then returns an object of this type. Okay. Content will be the string part, and then the source, yeah, can be email, chat, or okay. We see. Okay, yeah, we see. If the input is a string, source should be source should be email, then content should be that input string, should be input string. If it's an array, source should be chat, and then content should be a string. Okay, it should be a string, but use the joint method to join them together, to join the items, the string items in the array together with a new line character. So it will be like a string, a stack, if you might say. Okay, stack of string. Otherwise, so should be string unknown, and then content should be empty. Okay, like this is, I don't think I'll code the use. To check if the input is an array, you would use this method. You wouldn't use type of. Although, what does type of say? You just do. What does type of? Okay, let's just do string, and then this is can't. If Okay, like I just want, okay, let's just console log. Just want to see what it does. Like, it doesn't work on array type of, and then we'll do strings. Yeah, it doesn't work on array, right? Okay, yeah, okay, it's used before it's being assigned. Shut up, man. Okay, let's see. It will return an empty string. Oh, it will say object instead of array. Okay. Yeah. Okay, anyways. We get that. Okay, thank you. I had to make sure what it does. Okay, to say objects because basically everything is like an object. Okay, I like this coloring, and I like this. This is what I like right here. The hierarchies of like the types and stuff. Okay, type hierarchy. All the types in TypeScript can be arranged into an hierarchy of sorts. I've done one below. Okay, up, widening, assignable to. Yeah, it does down, narrowing, notch, any down. Okay, see. Widening, assignable to. Okay, these are all the types again, and then these are the string, literals, unions, number, string, boolean, true, false. Okay, number, and then string. This is string, or this, and then they can both be of type never. Below, void is undefined or now. Then any or unknown. Yeah, any or unknown can be any of these, and then string can be any of these. Number can be any of these, boolean can be any of these, and then void can be any of these. Okay, this is interesting. This is a huge blob of text. Obviously, I didn't list every type. Okay, this which one is left? He listed all, man. Which one is left? These are all you need. Obviously, I didn't list every type, but the goal is to show you how narrowing works in TypeScript, and what should you get? Some key points. The type at the top of hierarchy are the widest. Yeah. They said wide. They're the widest because they can be anything. At the widest, they encompass the most possible values, and very little is known about them. The types at the bottom of the hierarchy are the narrowest. They encompasses the fewest possible values, and a lot is known about them. Any and unknown are at the top of the hierarchy. The weird one is actually the any type because it just breaks all rules, allowing you to do whatever you want with it. Never is at the bottom of the hierarchy because it represents values that can't okay. Types below are assignable to the connected types above them, but not the other way around. For example, amin is assignable to this, which is assignable to strings. Yeah. Anim is assignable to this if this is a narrowed like yeah. It's assignable to this, and this is a string. Yeah. Okay, assignable to string, which is assignable to any. Yeah, I mean it's not assignable. This a string union is not able to this. It's not assignable to this because what would happen if the value happens to be alien? Interestingly, undefined and null are assignable to void, at least when strict null checks is disabled, but not the other way around. Your assignment. Our AI logic uses sentiment analysis to algorithmically deduce whether the feedback is positive or negative. Compare the response to sentiment function. Yo, the code is full of errors. Complete the response to sentiment function with there is a okay, so it is returning a response. Response is of type this, which is an object of string boolean. So yeah, this just wants a response. You just return any object that satisfies this, and it will work. This end up positive. Okay, let's see. If input is positive, if the input is positive, pass it to the handle positives. Okay, handle positive. Okay, and this is negative. You pass it to the handle negative and return the result. If the input is anything, return the message we don't understand, but the message that should be returned should be of type this we don't understand. Okay, notify the manager. If the input is happy, the response should be hooray. Don't notify the manager, so it will be false, here it will be true. If the input is satisfied, we're glad, and then false. Complete the handle negative function. If the input is satisfied, we're sorry, and then false. If the input is angry, we're sorry, and then true. Whatever. Move. Narrowing using in. Okay. A keyword. The in operator checks if a property exists in an object, which is fantastic for type narrowing. In object literal, so you have this type, you have this type, have this type, and then we're doing some type union there, and content in message, and then we use if content in message. Okay, so it will use the one with content. Okay, TypeScript knows this is a text message because it is the only one with it is text message because it is the only one with content. This is really smart. No, this is because it's the only one with property. But what if like there are two with content? Then I guess it will fail. Take the first one. No. I mean, it would fail. Oh, what would you do in that case? Okay, discriminated unions versus in checks. I like typed unions. Okay, I'm gonna be using them in the coming projects. How many are we left before we start doing projects? I think we are approaching, guys, 10. Only 5 days after today. There's gonna be like 5 days before I start doing project. Oh my god, I'm so excited. Discriminated unions versus in checks. You might have noticed that this kind of logic feels very similar using discriminated unions, and you're correct. Here's some types with an explicit discriminant property, kind, whatever. Okay, and then they would just check kind itself. So the thing that's passed in the function parameter dot kind, if it's equal to video, then if it's equal to image, then if it's equal to text. Then my recommendation is to prefer discriminated union when you have full control of the type. But if you're using types from a library or package, or you have another reason you don't want extra properties, the in operator is a great alternative. Use take the unions, guys, instead of just checking like if it is this. As I've said, like what if like this object also is like a content? So yeah, it would be a problem. The assignment: complete the process attachment function. You should return a string based on the given. Now we're going to program. It's time to program now. Okay, the process attachment method, it should return a string based on the given attachment using the in operator. Okay, we need to create a new. Let's turn on the lights. We need to do in.ts. Boom. Then put that there. Test can remain, and it's too bright here. Okay, we're gonna use the in to narrow the types. Okay, using the in image. Okay, let's see. Image, return string, return the string, attached image. Okay, attached image, size dimension. Okay, replacing the size with the respective fields. Document. Okay, what is the string? There's nothing with the string. Image, there's nothing with an image. Okay, for image, okay, for images. And then for document, then would use, what would you use here? Would use maybe with, you would use num pages and file size for this one. See, because in like checks like the key name. So like, see, like what if they've like similar? That means you can't use them in using in, right? Like this is why tagged unions or discriminant unions would have been better, right? Otherwise, return a string, the string attached to okay. So we just use the property that others don't have. I hope you can see. yeah, here we just use the properties that others do not have. So we do if let's use width, and then we do string. So we do width indoor attachment. If within attachment, then what string are we returning? Yeah, we're returning the string attached image, whatever. And then we need to return this string. So here we'll come and do $sign, and $sign. So I need to remember how to use those git those what are they called? Else if the Vim motion. I think I have Vim enabled. I just need to press. I need to enable them, but no, they're gonna slow me down. It should have been a great combo to learn to program in parallel, replacing sites again. To learn programming in parallel with getting familiar with Vimotion. It would have been a huge win when you write projects, so I actually go faster. Okay, in the coming, I'll do tomorrow. I'll start doing that tomorrow. I know, like, I could just do, I think it's WB is going back, and then this WR, I think it's going forward or whatever, by Karawara. Okay, I forgot. So we need those sizes there. Okay, size, yeah, put a percentage. Okay, size would just be, yeah, they're not even capital there, so it will be attachment dot file size, and then here it will be attachment dot width, and then here it will be attachment dot height, and then delete everything that's there. Okay, then here it will be, yeah, we just did else if we'll put the logic later. Attachment dot, this will be for document, so we'll have a file size, and then we'll have attachment dot, this navigation coming from attachment dot nums pages. So like the LSP is not working because we haven't narrowed, so it will be, we'll be looking for num pages in attachment, then here it will require this. Okay, else we were supposed to return some string with, okay, just a file size. Okay, and then you can just do else. I shouldn't have coded. I'll code now when like the problem is challenging for my well-being. So yeah, this is what the thing wanted you to do. Narrow a few types, and narrow a few types, do that. Okay, we got it using the in keyword, because that's what we have learned. I could have changed them to tag unions, but that's not what we were learning. Type predicates. Sometimes the built-in type guards type of instance of heteros are not enough. We haven't really talked about instance of type of I know it, instance of I forgot. TypeScript allows you to create your own type guard using type predicates. We do that by creating a function that accepts a wide type that we want to narrow. Okay, this is your type guards. TypeScript allows you to create your own type guard using type predicates. Allows you by creating a function that accepts a wide type that we want to narrow, returns a boolean indicate if the value is of the desired type, and then use the type predicate syntax. Value is type in the return type. For example, here's a function that reports if value is a string. Is string, oh my god, you wouldn't want to do this. Okay, value is string, return type of value equals a string. Then, oh my god, what syntax is this? Okay, value is string. So this is type predicates. Wow. Okay, value. Okay, if value is string, okay, yeah, it's just asking question. It's value string. It's a boolean. Then that, and then in process value we have a string value. Passing that TypeScript knows that the value is a string here. Console log to uppercase. Okay. For simple stuff like this, we could have just inlined the type of, yeah, we would have done this. But type predicates become very useful when the logic to check the type is a bit more complex. So we have a situation where one type, in this case the manager admin type, shares properties with both other types. Okay, manager admin shares access level number. Okay, it shares this access level with this one, and number employees with a manager. Okay, we can encapsulate the slightly more complex logic in this type indicates. Okay, we can encapsulate the slightly more complex logic in a type predicate function. Is manager admin boss, which can be blah, 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 and then boss is manager admin, and then employees inbox. Then you've name employees inbox and access having boss, then to be truffles. Then here is manager admin. Use it. TypeScript will know that the boss here will be a manager admin. Okay, I need to code this to like really bury it in my brain. Okay, so assignment. We support multiple LLMs. Those per token prices aren't gonna arbitrate themselves. Anyhow, we need to write code to activate a specific model when starting a chat with a customer. Okay. Fix is model skippity. Oh my god, this model skippity. Okay. Fix is model gene. There's a function. Okay, fix. There's a function called this model gene that returns, that like makes sure that the model is merging by using the end. Okay, think in model. Yeah, if think is there and or any version, we have to like we have to check for like where is it model gene? Where is it? Like I was checking the wrong code. Yeah, to be 3.pi or whatever. It's in pi, it's 3.14. Complete the activate model function. If you get a given customer, the activate model function. If a model is skippity, if a model is skippity, return the activated model skippity version with searching status. Return the string. Okay, let's see. Then we'll send the string searching status. What's the status? Version is simply the version, and then status is either enable or disable based on the search property. Okay. If the given model is gene, return string activated. Yeah, we're going to have to program. I might end at level 5 because guys, I'm a student. I can't go for hours programming. The thing is that I can, but then I'm gonna be tired to go practice. Like I'm doing 5 modules this semester, maths, and then 2 computer science. So it's no way. I might end by programming this and then calling it a day. Tomorrow we'll pick it up from there. Cause no way I'm gonna be like spending hours programming. Cause like there was time for revision to like for 80 minutes I was revising what I did yesterday. So yeah, that's that. Okay, so just gonna create the function. We didn't even copy the code. And you know what we need to do? We need to do this, man. It's wasting our time here. Okay. I just need this, man. Can we shrink it any further? Yeah. Oh. But anyway. Okay. Hope you can see. Okay, fix the skippity model. It should be a type predicate function. So to check if model is something, yeah, if the past model is something, yeah, let's check. This is why I like to write code. You see, like even the syntax, okay, is what it should be what predicate function. Fix its model. It should be a type predicate function. Fix its model gene by also making it a type predicate function. So its skippity should be a searching model. So it should be of type model. No, it should be type this, right? I'll write this. Can't I just say, oh, it's type model? No. Wait, it wants a boolean? No, it's not a string. It's what? Aren't we doing the syntax correctly? Oh, we do this, I think. Man. And then we'll just do model skippity. It should be that, right? Which has like search and version. And then fix its model gene by also making it a type predicate function. Here we'll just check if model is your model think. Which one is think? It's model gene. Okay, it's model gene. If it's that, complete the activate model function. Let's see this function, completing it if the given model is skippity. If can we use type of? No, you can't do type of. Okay, so we do. Okay, but okay, this has already been narrowed. So let's see how we're using it. Okay, we just pass in. Okay, we just pass. Okay, yeah. Okay, we just pass if is model skippity and then pass in the model. Then we'll do. Yeah, this is why the return this thing. This is why I program, because like you think you got the syntax, but when you start to write the syntax, you realize actually start being foggy now. Like dot here it was version, and then model the status, then model dot till I get type. Okay, let's do model dot. Where's model dot? Model dot. No, it's version model dot. This model dot version and model dot what in skippity search. Oh, status, man. Status. Like there's no status. Searching status. When the status. Oh no, it's a boolean. So yeah. Just do model dot search, and then it will be the status. It's simply the version property. Status is either enabled or disabled. Okay, so here we would need to do If it's true, we do enabled. False, we do disabled. Okay. With that, okay. Based on the search property, yeah. And then else, if there is gene, right? This model gene, passing the model, TypeScript will know, yo, here it will be gene, okay? Test will know what's up. Yeah, that's totally unnecessary. So we return this activated version with whatever. Okay. Then model.version. Okay, we need some we need some autocomplete version. Then the okay, it's gene version. Just return the version based on the thing property. So here we'll return. Okay, let's do that model.think. Then we'll do question mark. If it's true, we'll do enabled. If it's false, we'll do disabled. And that's that. Okay, there's no other way it should be those two, so shut up. Okay, so with a few tests here. So what is the function we're calling taking? Activate model. It's taking in a model which can be of type this. Okay, so it takes a version and whatever. So to be this object. That, do this, then just so you can see the return result. Okay, set stick to available disabled. Okay, so that does that. So I'm just gonna end the video here. It has been to be a close to 40-minute video. I cannot go any further. It's just I still need to be fresh when I go do my other school stuff. Thank you for watching. Grateful every day, even when now there's no viewers. I'm just doing it to just stay consistent, learn every day, upload the video as proof that I learned, and then go study. That's like what my life has been for the past, I don't know. So see you on the next one. From me to you. Bye bye.